Imagine a world where the only exhaust from your car is pure water vapor. A future where power plants hum quietly, producing clean electricity without a trace of harmful emissions. This isn't science fiction, it's the promise of hydrogen fuel cell technology. Are you ready to dive into the chemistry that could revolutionize our energy landscape? Welcome to the Clean Energy Journey YouTube channel, where science meets sustainability. We share how green energy will save our planet in the future. Hydrogen has earned its nickname as the fuel of the future for good reason. Unlike the fossil fuels we've relied on for centuries, hydrogen doesn't release carbon dioxide when used in a fuel cell. Instead, it offers a clean alternative that could help us tackle climate change head-on. But what makes hydrogen fuel cells so special? It all comes down to their ability to generate electricity directly from a chemical reaction, bypassing the inefficient and polluting process of combustion. At the heart of every hydrogen fuel cell is a fascinating dance of atoms and electrons. Picture two electrodes, an anode and a cathode, separated by an electrolyte and aided by a catalyst. When hydrogen gas enters the anode, it's split into protons and electrons. The protons pass through the electrolyte, while the electrons are forced to take the long way around, creating an electric current we can harness at the cathode. These particles reunite with oxygen from the air, forming nothing more harmful than water. This elegant reaction continues as long as we supply hydrogen and oxygen, producing a steady stream of clean electricity. It's a process that's not only environmentally friendly, but also remarkably quiet and efficient. Hydrogen fuel cells come in various flavors, each designed for specific applications. Proton exchange membrane fuel cells, or PEMFCs, are the lightweight champions perfect for vehicles. They start quickly and operate at lower temperatures, making them ideal for cars and buses. On the other hand, solid oxide fuel cells, SOFCs, prefer the heat. These high-temperature powerhouses are better suited for stationary power generation, providing electricity for buildings and factories. But the list doesn't stop there. Phosphoric acid fuel cells have found a home in commercial buildings, while alkaline fuel cells once powered astronauts to the moon. For industrial-scale power, molten carbonate fuel cells step up to the plate. Each type has its strengths, balancing factors like cost, efficiency, and operating conditions. The advantages of hydrogen fuel cells are hard to ignore. First and foremost, they're champions of clean energy. The only emission from a hydrogen fuel cell is water vapor. No greenhouse gases, no air pollutants. They're also incredibly efficient, converting more of the fuel's energy into usable electricity than traditional combustion engines. Another major plus: fuel cells are quiet operators. Unlike the roar of a gas-powered generator, fuel cells hum along almost silently. This makes them versatile enough to power everything from small, portable devices to massive power plants. Perhaps most exciting is the potential for energy independence. If we can produce hydrogen using renewable energy sources like solar and wind, countries could break free from their reliance on imported fossil fuels. However, it's important to acknowledge that hydrogen fuel cell technology isn't without its challenges. Currently, most hydrogen is produced from natural gas, which still results in carbon emissions. While we can make green hydrogen using renewable energy, it's currently more expensive. We also face a classic chicken and egg problem with infrastructure. There aren't many hydrogen fueling stations yet, which makes it harder for fuel cell vehicles to catch on. There are also some inherent inefficiencies in the hydrogen energy cycle. Producing, compressing, transporting, and using hydrogen all require energy, leading to some losses along the way. Engineers are still working to improve the durability of fuel cells and find alternatives. Too expensive catalyst materials like platinum. Despite these hurdles, hydrogen fuel cells are already making their mark in the real world. In the transportation sector, fuel cell electric vehicles are hitting the roads. From passenger cars to buses and even experimental aircraft, hydrogen is proving its worth as a clean fuel for mobility. Hospitals and data centers are turning to fuel cells as reliable backup power sources, ensuring critical operations continue even when the grid fails. Heavy industry is another frontier where hydrogen shines. Sectors like steelmaking, chemical production, and shipping, which are difficult to electrify with batteries alone, are exploring hydrogen as a path to decarbonization. Looking to the future, the potential of hydrogen fuel cells is closely tied to the development of green hydrogen production. Imagine using excess solar or wind energy to split water into hydrogen and oxygen through electrolysis. This green hydrogen could then be stored and used to generate electricity when the sun isn't shining or the wind isn't blowing, creating a perfect complement to intermittent renewable energy sources. Governments around the world are taking notice. Countries like the United States, United Kingdom, European Union members, Canada, and Australia are investing in hydrogen projects, offering subsidies and developing the necessary infrastructure. Many experts believe hydrogen will play a crucial role in achieving a net zero economy, particularly in hard-to-decarbonize sectors. Hydrogen fuel cells represent an exciting marriage of chemistry and clean technology. While they're not a silver bullet for all our energy challenges, they're undoubtedly a vital piece of the clean energy puzzle. As we continue to innovate, invest, and develop supportive policies, hydrogen fuel cells could transform the way we power our world. The road to a sustainable future is paved with scientific breakthroughs and technological leaps. Hydrogen fuel cells embody this spirit of innovation, offering us a glimpse of a cleaner, greener tomorrow. As we've explored the chemistry behind these remarkable devices, it's clear that they have the potential to revolutionize multiple sectors of our economy. From the cars we drive to the power plants that keep our lights on, hydrogen fuel cells could play a pivotal role in breaking our dependence on fossil fuels. While challenges remain, the promise of clean, efficient, and versatile energy is too great to ignore. As we continue our journey towards sustainability, hydrogen fuel cells stand ready to help us write the next chapter in our clean energy story.